Hi everyone, welcome to OpenAirInterface tutorials. In this case, we are going to talk about OpenAirInterface and GNURadio. So if you would like to have more tutorials like this, please help me and don't forget to subscribe the channel and hit the bell to get notifications about new videos like this. So the first thing we are going to do is to visit this place on internet. There is a guide tutorial hardware considerations in order to create an spectrum analyzer. So there is a small introduction, some prerequisites like GNURadio and the SDR. What will I need? At the end, we have some variables and some modules from the USRP in order to create the spectrum analyzer. So the variables or the parameters are related with the RF gain, the frequency, and the sample rate, and the USRP needs to be configured in this way. So those variables at the beginning, we are going to introduce it here in the configuration for the USRP in order to visualize the spectrum. This is the simplest spectrum analyzer we can create using GNURadio and the USRP. So we are going to launch the GNURadio companion after downloading from internet. And so you can see for band 71 the configuration of the USRP source, the GUI sync, and the GUI range in order to be able to visualize the spectrum analyzer. Here is the gain. The bandwidth, and before we solve the frequency. And here is the USRP source. We're going to RF options, and you need to put this information here. Then OK. And the GUI sync, also you need to put this information. We're going to change this for the spectrum analyzer. And for this one, we're going to see the plot for the frequency. The next GUI sync, we change the name also, but here we are going to see the plot waterfall. Apply and OK. Here is spectrum analyzer for the frequency, and the before GUI sync was for the waterfall. Apply and OK. And then we are going to run. This is a spectrum analyzer, but we need to increase the sample rate, the display RF frequencies, and we're going to hold the max and minimum values. Here, this is the spectrum we are going to we are seeing without transmitting any signal, RF signal. As you can see, there is the spectrum is not clear in this country. So if you see in the middle, we started to create a transmission using an LTE baseband, a base station, sorry. Also between 630 and 640 we see a spectrum that is related with television. Again, in 650 we launch a signal, an RF signal, using 5 megahertz of bandwidth. The central frequency is 650, and we are going to see after how we configure this value using OpenAirInterface and the configuration files. So we saw the lower frequency and the higher frequency, and if you can notice, we have 5 megahertz of bandwidth. In the middle, we see the SSS and the PSS signal that is used for synchronization. So the idea is to now move the central frequency of the transmission for LTE. So now we have changed for 647, and again 644 and 649. So we have 5 megahertz of bandwidth transmitting from the base station using an LTE signal in band B71. Now the idea is to increase the bandwidth. So before we had 25 physical resource blocks. Now we have 50 physical resource blocks. So it's the same of having a 10 megahertz of bandwidth. So from 642 to 652. Again, in the middle, we are seeing the PSS and the SSS signals using for synchronization. Now we launch the LTE base station use band B71 and using dash D option to visualize the signals. Like in this example, you can see the received signal, the channel frequency response, and additional constellations from the push and the PUCCH. So let's see in the configuration file how to change the central frequency as we saw before in GNURadio. So here we have a tracking area 600, the MCC 208 and the MNC 93. Here the downlink frequency is the central downlink frequency, and we have 25 physical resource blocks in the downlink part. So if we change this with 647 megahertz, we are going to move the central frequency to that value. Again, here in OpenAirInterface we see the signals, but in GNURadio we saw that we moved the central frequency 3 megahertz. So here in OpenAirInterface, we modified some files to be able to work with band 71, because this band is not this band doesn't come by default when we launch OpenAirInterface. So here band 71 was added. So again, we are seeing the received signal in the time domain for the band B71. But the spectrum was that we saw before in GNURadio. So here we can we can be sure that we are working in the signal with the band we need to work. So let's move to another band. In this case, band 12. This is the values for band 12. As you can see, here is the gain, but we have range for frequency and the bandwidth. So let's run for band 12, increase the sample rate to visualize and display RF frequency and hold maximum and minimum values. So as you can see, band B12 here in my country is completely clean. So in this moment we are to use the base station to transmit the signal, the LTE signal, with 5 megahertz of bandwidth, and the central frequency is 735. So let's see the values. 733 and 738. So we have 5 megahertz of bandwidth. So let's stop the transmission. And we are going to move the central frequency to another value. Here in this moment is 736. But before doing that, we increase the bandwidth to 50 physical resource blocks, or the same, that is 10 megahertz of bandwidth. In the middle, in the central frequency, we see also PSS and SSS, that is a signal that we employ for synchronization. So 731 is the minimum value and 741 is the higher. So we have 10 megahertz of bandwidth. Now let's move to the configuration files in OpenAirInterface. Here the central downlink frequency is 1736 as we saw in GNURadio. At the beginning, we had 25 megahertz of bandwidth, 25, physical resource blocks. And the next step we did was increase it to 500. So we launch here with another configuration file. We also employed the -D option to visualize signals. And here again we see the received signal and the channel frequency response. So let's see the configuration file, 736 megahertz, 25 physical resource blocks. That is the same of having 5 megahertz of bandwidth. If we increase this for 50 physical resource blocks, we have 10 megahertz of bandwidth. We launch this with the -D option, and we see the signals. Again, the received signal, the channel frequency response, and some constellations. So let's continue with band 7 from 2620 to 2690. As you can see here in the bands list, so we configure those values in GNURadio, apply an OK. Then we save, and we have an error here that is related with these values. Maybe it's too big, the range of frequencies, so the idea is to reduce those values in order to reduce this red signal or this error that doesn't allow us to go ahead. So now we update the values and we don't have errors. We run GNURadio for band 7. We increase the sample rate and we display RF frequency. We hold maximum and minimum values. So here in my home, we are seeing some small signals related with band 7, because here we have some mobile operators using this signal. In the right part, as you can see, in the center of 2680, we have a 5 megahertz of bandwidth. So the central downlink frequency is 2680. So in order to see a better signal, we are going to put this in the center. So we modify the range for the frequency to be able to see the signal in the center of the figure. So let's increase a little bit, apply and OK. Let's run the band B7. So now in the middle, increasing the sample rate and holding the maximum and minimum values, showing the frequency, the RF frequency, we see in the middle of the figure the signal we are transmitting. This is a LTE signal using a 5 megahertz of bandwidth. So the center frequency is 2680. We stop the transmission. Next, we change the downlink central frequency. So now the transmission is here in 2670 with 5 megahertz of bandwidth. So this is the end of this tutorial. So in order to wrap up the information, we saw how to interact with OpenAirInterface in order to transmit a signal and then receive that signal using the GNURadio, and by employing the spectrum analyzer, we visualize the signal, and we are able